Hi there, Turgeon here, bringing you physics from afar. I have some hints on the egg drop challenge, especially the data table, so let's go right to that. You're going to want to break this up into 8 columns, even though I know it shows 6. So it's a little awkward, but maybe there are 2 here, and then we could do an additional 2 here, and then the rest of these will be a column apiece. Okay, in this first column, oh, and by the way, this is all going to be audio because I want people to hear the explanation really quick. The first and most important thing is that every one of these columns is something that we talked about in the entries. And a little hint here is if you scroll down to the bottom, you can actually expand. If you have you all have access to the Google Docs, you can expand this image and see a version of what we talked about. It won't look exactly the same. But this this first column here, this one, let's call this the height that it was dropped from. Okay, so this would be, and some of you only dropped from a few heights. I forget what I said for the requirement, but you could just add additional heights of 1 meter, 2 meter, 3 meter, 4 meter, okay? And then from that, this column is going to be the potential energy. You can calculate based on the mass of the egg, which we agreed is going to be 55 grams, which is 0.055 kilograms. That potential energy becomes the kinetic energy. So we have height, potential energy, kinetic energy. That kinetic energy can be used to calculate the final velocity just before hitting the ground, which is going to connect to the impulse momentum later. So these are all energy. These columns are all related to energy. Then we move over to what I like to picture here is that it's like we have the we have an equation going here. It's that really important impulse momentum equation, which is Ft equals m delta v. So we can put the force here, which is just 25 newtons all the way down. We have the time of impact, which is interesting. That's the duration over which that impact occurred. And all of this helps down here with question 5. Everything I'm saying is kind of relating there. So this we don't know, actually. We don't know the time of the impact. You're going to explore that relationship of the time of the impact. So then here we have the mass of the egg, which is constant everywhere, so that's interesting. And the delta V relates back to here. This column here was the velocity, the final velocity, and then the delta V is equal to the final velocity. If you think about why that's true, it's because you have this maximum velocity. This is final, or also known as maximum velocity, this one right here. I hope my pointer is showing up on the video. So the final velocity, the maximum velocity, then you could think of as becoming a final velocity of 0. We talked about that in the entry. And then that means there's a change in velocity that happens to be equal. So if this was like 17 meters per second, it went from 17 meters per second down to 0. So the change in velocity is 17 meters per second. You can solve and you can find what these times are. And that's going to relate, it's a major, major hint. That's going to relate to what you put down here, explaining from your data table. What should we do to protect the egg? And you're going to speak in terms of these 4 variables here. You're going to speak in terms of these 4 variables here with the equal sign right here. Ft equals m delta v. Talk about how we protect the egg in terms of the force, the time, the mass, and the change in velocity. So now super quickly I'll just remind you of the various things. Everybody, it's very rare that somebody doesn't meet the basic requirements, and then you can add all these elements on paper. Even if you want to do this on white line paper, that's fine. We talked about item 2 a lot. There's stage 1 and stage 2. You can describe those in words. and then doing a sample calculation for all aspects. So that means you've got a stage 1 and a stage 2. And then you can show some more calculations here, and then you're answering the questions, and then you're good to go for your egg drop project. This has been Turgeon bringing you physics from afar.